Temporary epicardial pacemaker leads are routinely placed on the epicardium during cardiac surgery. Typically, the surgeon loosely sutures epicardial wires to the right atrium and the right ventricle before closing the chest. The wires attached to the right atrium exit the chest on the right side of the sternum. The wires attached to the right ventricle exit the chest on the left. The importance of these leads are most evident during the postoperative period, when dysrhythmias are common secondary to electrolyte imbalances, myocardial injury, edema, and hypothermia. In caring for patients with epicardial pacing wires, you'll need to ensure that the wires are properly managed and ready for action at all times. For teaching purposes, it would be best to do this module with an actual pacemaker generator to refer to. By convention, the leads exiting the right side of the chest are the atrial leads, and the leads exiting the left side of the chest are the ventricular leads. Some institutions color code the atrial and ventricular leads to abate confusion. Make sure you check if your institution has any such standards. While epicardial pacing wires are meant to provide a safeguard against dysrhythmias, they have the potential to cause a lethal rhythm. Unattached wires provide a direct route for electrical current to flow to the heart, especially in the form of microshocks. Microshocks are low-voltage electrical current from ungrounded equipment or static electricity. Only allow battery-operated devices, such as radio or shaver, at the patient's bedside. Make sure that all electrical equipment in use is grounded. Remove any device that doesn't have a grounding pin on the plug. If the patient's bed doesn't have a grounding pin, or the grounding pin is broken, unplug the bed and leave it unplugged until the pacing wires are removed. Always wear gloves when handling the wires, and always keep the wires insulated by having each wire covered separately. This is an example of a dual temporary pacemaker generator by Medtronic. Let's review some basic key features. This is the on and off keys. Click once for on and twice for off. These are the atrial pacing and sensing LEDs, and these are the ventricular pacing and sensing LEDs. We will discuss this in detail in a few minutes. This is the lock/unlock button. The locked icon is displayed in several areas of the top of the screen. When locked, the rate, ventricular output, and atrial output cannot be changed. The first large round button from the top controls the heart rate. The second round button controls the atrial output in milliamps. The third round button controls the ventricular output in milliamps. The fourth round button controls the menu parameters of the lower screen. This is the selection key, and this is the menu key. By definition, sensing is the ability of the pacemaker generator to see if the heart has an intrinsic rhythm. If the patient does not have an intrinsic rhythm, the sensing light at the top of the pacemaker will not flash. A word on sensitivity. Let's use a window shade analogy to explain sensitivity. If the window shade is wide open, an EKG complex can come through and more likely evade detection. If the window shade is down and almost completely closed, then there's a higher probability of detecting the EKG complex. The pacemaker generator works similarly. When your sensitivity is high, your window is wide open, and some EKG complexes might come through and be missed. Conversely, when your sensitivity is low, your window shade is low, which would make it easier to detect the EKG complexes. When you set the sensitivity on the pacemaker, try to pick the lowest number because we want to be as picky as possible, and we want to be able to see and not miss as many EKG complexes as possible. Capture occurs when the pacemaker generator sends out electrical current that successfully stimulates the heart to beat. This is what atrial and ventricular capture looks like on EKG. Notice the pacer spikes before every P wave and widening QRX complex. Do not test ventricular and atrial threshold if the patient has no underlying intrinsic rhythm. Make sure the rate on the pacemaker is set significantly lower than the patient's intrinsic rate, in this example 50, and turn A output to 0 and the V output to 0.1. Setting such a low ventricular output to 0.1 prevents pacing. Next, go to the bottom screen, press the menu key and then select key until it highlights the V sensitivity. Notice the V sensitivity light at the top of the pacemaker. It should flash at the rate equal to the patient's heart rate. To determine the V sensitivity threshold, increase the millivolts using the round knob until no sensing is detected and the sensing indicator stops flashing. By doing so, you have opened the window and you're not being as picky. By not being as picky, the pacemaker generator assumes there is no QRS complex. Next, set the V sensitivity to half to a third of the sensitivity threshold, or 0.8 millivolts. Remember, no pacing should occur because of the low V output of 0.1 that was set. The V sensitivity indicator should now flash continuously. Set the pacer rate at least 20% above the patient's intrinsic heart rate. Pacing is still unlikely since the V output is only 0.1 milliamps. Slowly increase the V output milliamps until you see continuous capture spikes depicted as a wide QRS complex. This is the capture threshold. The pacing light should now be flashing. Immediately turn the pacer rate below the patient's intrinsic rate, for example 50. This is called the backup rate. If the patient's intrinsic heart rate goes below 50, ventricular pacing will occur. The V sensing light should now flash because sensing is now occurring and pacing is not. Set the V output milliamps at 2 to 3 times threshold, if possible, otherwise to a maximum of 25 milliamps. Atrial sensing is done in the same manner as ventricular sensing and can only be done if A wires are present. Keep the heart rate at 50. Keep the V wires plugged in, but change the V output milliamps to 0.1 so ventricular pacing does not occur while testing the A wires. Sometimes it helps to write the V output settings so that you don't forget. Next, go to the bottom screen. You may need to press the menu key until atrial sensitivity is highlighted. Using the round knob, increase the atrial sensitivity millivolts until the pacer no longer senses, which is depicted by the sensing LED no longer flashing. This is the sensitivity threshold. Set the sensitivity to half to a third lower than the threshold, or 0.4 millivolts ultimate sensitivity. Remember, no pacing should occur because of the low atrial output of 0 that was set. The atrial sensitivity indicator should now flash continuously. To test for atrial capture, increase the pacer rate again to approximately 20% above the patient's own heart rate. Pacing is still unlikely since the atrial output is only 0 milliamps. To test for capture threshold, increase the pacer rate to approximately 20% above the patient's own heart rate. Start increasing the atrial milliamps until capture occurs. This is the capture threshold for the atrium, depicted by a narrow QRS complex, unless the patient has an intrinsic bundle branch block. Set the atrial output milliamps at 2 to 3 times the threshold, if possible, otherwise to a maximum of 20 milliamps. Once done, don't forget to hit the lock button. Also, keep pacemaker generator visible at all times in case of emergency and prompt need. In summary, pacemaker sensing and capture interrogation can be done in 5 easy steps per chamber. Make sure you set the backup heart rate and lock the pacemaker generator when you're done.